Okay. All right. So we're going to figure that out right now. All right. So two things I want to do. We want to be able to define, well, I don't have that there, but define center of gravity. We're going to talk about stability, equilibrium. We're going to talk about an experiment that we use to determine the center of gravity of an object when it doesn't have a regular shape. We're going to talk about toppling, and at the end of the day, you will be able to look at an object and determine just by its shape and the way that it's standing whether or not it will topple over. Okay, so first thing, what's center of gravity? Sometimes it's also called center of mass, depending on which textbook you're looking in. But it's a point on an object where the entire weight of the body appears to act. Okay, so you can think of it as the spot where if you were to draw a point on that object to say, okay, this is where gravity is pulling on this object the most, that would be the center of gravity. For regularly shaped objects, so squares, rectangles, circles, anything that has a geometric shape that's made of lines or points connected, then we can easily find their center of gravity because it's always going to be at the geometric center. So for squares, that's easy. We know that the center of a square is the point where two diagonals that come from the corners of the square or rectangle where they would meet. For a circle, we know that the center of the circle, that is where, if we were to draw an infinite amount of diameters across that where they meet, then that would be the center. Okay, for triangles, it's a little bit more complicated, but the point is, any geometric shape has its center of gravity at its geometric center. Okay, so that's the first point. But what about when the objects are not nice shapes like squares or rectangles? When that is the case, then we have a method that we can use, and this is sometimes used as a skill A for BGCSE. It's called the plumb line method. And we're going to watch a video to show you exactly how that experiment is carried out. The aim of the experiment is to determine the center of gravity for an irregularly shaped object. If we were in class, we would usually do this with a piece of cardboard, and we would take a nail or a pin and we stick it up on the wall, and we take some fishing line or some string, and you can use string, or sometimes you can just draw a line. We usually just draw a line with a ruler. So you just make 3 holes anywhere along the edges of the piece of cardboard, and then we draw a line from one hole to the next, and where those lines meet, that's our center of gravity. So I'm going to show you a video, and we're going to look at that.
Gravity. Try to balance a piece of cardboard on your fingertip. You observe. We observe that there is only one point on which the cardboard can be balanced. This point, where the cardboard can be balanced, is called the center of gravity of the cardboard. Thus, the center of gravity is the point through which the resultant of the weight of all the particles of the body acts. Let us now define the center of gravity of an irregularly shaped lamina using a plumb line. Make 3 holes near the edge of the lamina so that the lamina can swing freely when pivoted from a hole. Suspend the lamina from the point P as shown here. Hang a plumb line from the point P and mark the plumbing line P' on the lamina. Repeat the experiment by suspending the lamina from Q and mark the plumbing line Q'. Now follow the same procedure for the point R.
All right, so we were defining stability, and we're talking about the two things that can affect stability. Number one is the position of the center of gravity. The lower it is on the object, then the more stable the object is going to be. Second is the width or the base area. So the wider the bottom of the object, the more stable it's going to be. Okay? And you can think about that. Think about when you are walking in flat shoes versus when you're walking in stilettos for girls. Okay? You have to be a little bit more conscious of keeping your balance when you're wearing the high heels. A body or a system is going to remain stable as long as the line of action of the weight does not act outside of the base area. Okay, and the line of action is just an imaginary line that's drawn from the center of gravity down, straight down. Okay, so if you look at the two persons, when the person is standing with their legs close together, they are stable, okay? But the person who is standing with their legs further apart, they would have a wider base that they're covering, so they would be even more stable, okay? And of course, if you think about, if we put another person on the other side and they're standing on one foot, okay, I'm still recording. And they're standing on one foot, they would be what? Definitely, they would be less stable than the person standing with their feet close together. Okay? All right. So let's talk about what happens when an object is not stable. We have what we call toppling that will occur. So literally, it will fall over, it will topple over. Objects that have high centers of gravity, they are going to be more susceptible to toppling. If you think about the way that a race car is designed, are they really tall? It's like a double-decker bus?
No, Mom.
No, they're nice and sleek, and they're low to the ground. Like if you try to sit in them, your head would probably touch the roof, and they're built that way for a reason. They're built that way so they can have a low center of gravity because they're going fast and they're turning corners, and as they do that, they are adjusting their center of gravity. So they want to keep as low to the floor to avoid turning over when they are moving that fast. Okay? Driving fast with a high center of gravity equals what?
Toppling?
Yep, toppling over, which is why, here in Nassau, we hang on to our seats when we're in those jitneys and they're trying to drive like they're a race car. And they're not built for that. They are not built for driving fast. There's a scientific reason for that. Okay? So this one here, the black car that has a lower center of gravity, when it turns, it might lift up off the ground, but it will come back. Okay? This one that has a high center of gravity, if it takes a turn too fast, it will lift off the ground and it will topple over. It will stay on the ground. Okay? So what I mentioned just now about lifting up off the ground and top and coming back is what we call equilibrium. So just because an object tips over doesn't necessarily mean that it's not stable. Okay? You can have changes in an object's center of gravity or changes in its position even without it toppling. When an object is stable, it's said to be in one of three states of equilibrium. Equilibrium means a state of stability. And there are three ways that an object can stable. The first one there are three ways, that an object can be in equilibrium. The first one is called stable equilibrium. The object, if we give it a disturbance, if we tip it, it will tip over and come right back to its original position. The second type of equilibrium is called unstable equilibrium. If you touch it, it will tip over, but it won't come back. It will stay on the floor. So you knock it over, it stays on the ground. It doesn't come back to its original position. And the third way, if you push an object and it moves its position but doesn't tip over, then it's said to be in neutral equilibrium. Okay? Three types of equilibrium: stable equilibrium, unstable equilibrium, and neutral equilibrium. Let's take a look at what objects in those three states might look like. All right, so here's the first one here, stable equilibrium. Notice that it has a wide base, okay? If you tip that over, it will lift up off the ground similar to the car, but it will come back down. Restorative forces will act on it to bring it back to its original position. This one, the cone that's standing on its tip at the bottom, if we give that a push, it will tip over, but it won't come back. It will just fall on the ground and it will stay in that position. That is unstable equilibrium. Okay? And finally, we have objects like a tennis ball, soccer ball. If you kick it, it will move position, but it won't tip over, okay? Because it's round. What I mean by it won't tip over is its center of gravity will remain in the same place. Okay? Let's take a look at what that looks like. I'm going to show you another very short video, and we are just about done. I want you to look at what is going on, and I want you to tell me what type of equilibrium is being demonstrated. All right, so I'm going to pause at intervals, and you tell me what's going on. What kind of equilibrium is that? Is it
Stable.
neutral? Is it unstable or stable?
Stable equilibrium.
How do you know?
Because it doesn't topple over, it goes right back to its place.
Good. What's another characteristic of an object that will be in stable equilibrium? What do you notice about the base?
It has a wider.
Wider base. Good. Let's look at the next one. Okay, he's going to be doing that for a while. We want to fast forward a little bit. All right, what about this situation? Let's watch what happens. Which one is that? Which one did you see just now?
Unstable.
Very good. Unstable. Okay, topples over, does not return. And last one.
B?
Yes, it is B. Okay, so we're just looking at the base. So we're looking at geometric shapes. Basically, they're all regular shapes. And we know that the center of gravity has to be in the middle, in the center. So the only one that's correct is B. All right, good. So last question. This is something fun to think about. Who is clumsier? Well, we only got girls here today, so we could talk about the boys while they're not here. Who's clumsier, girls or boys? What do you think? So you've heard, your parents might have told you, you know, girls are supposed to be graceful. Girls are, girls are supposed to walk softly, and we're supposed to be all prim and proper and poised. Okay? There's a reason for that. There's a scientific reason for that. Male and female bodies actually have different centers of gravity. Because of the way that the mass is distributed, you know, boys have the muscles up top, and girls, when we get a little older, we have the thighs and the hips at the bottom. Well, the center of gravity for a woman is at the bottom near her hips, while the center of gravity for a man is more, you know, at his waist and abdomen area. So for that reason, who do you think is more graceful, scientifically speaking?
Females.
Yep, it's going to be yes, females, okay? Because remember, the lower the center of gravity, like the race car, the more stable an object is going to be. All right?